Gravity. It's the force that binds us to the Earth, keeps the planets orbiting the Sun, and holds galaxies together. But at the scale of the entire universe, gravity doesn't just shape structure, it shapes destiny. The fate of everything we see is tied to how gravity battles against the universe's expansion. You've likely heard that the universe is expanding. Space itself is stretching, carrying galaxies farther apart over time. But this expansion is not constant. It's a battle between gravity, trying to pull everything back together, and something else, pushing it apart. That something else is known as dark energy, a mysterious force responsible for the accelerating expansion of the universe. But long before dark energy dominated, gravity was in charge, forming stars, galaxies, and clusters from the primordial soup of the Big Bang. The early universe was a playground of gravitational competition. Regions with slightly higher density collapsed under their own gravity, forming galaxies. Others remained empty, creating the vast cosmic voids we observe today. But what about the long-term picture? If gravity were stronger than dark energy, it could have halted the expansion, even reversed it, causing the universe to eventually collapse in a big crunch. On the other hand, if dark energy wins completely, the universe may accelerate forever, ending in a big freeze or perhaps a big rip, where even atoms are torn apart. Current evidence suggests we're headed toward an ever-accelerating expansion, a slow, cold fade into darkness, where galaxies drift so far apart that light can no longer travel between them. But nothing in cosmology is set in stone. In fact, gravity continues to surprise us. Recent discoveries show that gravitational waves, ripples in space-time caused by massive collisions, may play a larger role in transferring energy than we once thought. These waves stretch across the cosmos, carrying the fingerprints of violent events like black hole mergers and neutron star collisions. And gravity may not behave the same everywhere. Some theories suggest it could vary across large distances or change depending on the density of matter. If true, it could rewrite our understanding of cosmic expansion and the universe's fate. At infinity beyond, we see gravity not just as a force, but as a storyteller. It sculpts galaxies, governs the life cycles of stars, and silently decides how the cosmos will end. Whether we face a cold death, a fiery collapse, or something far stranger, one thing is clear: the universe is a dynamic, evolving entity, and gravity is at the heart of it all, a quiet architect with the power to shape everything.